Hello guys, here we back again. But now we have a different project which I can say it is an important project. It is prosthetic arm. So first, what does prosthetic mean? A prosthesis or prosthetic implant is an artificial device that replaces a missing body part, which may be lost through trauma, disease, or a condition present at birth. According to a worldwide statistics reported in 2017, 57.7 million people were living with limb amputation, about 36.2%, due to traumatic causes, about 15.7%, due to road injuries, 11.2%, due to other transportation injuries, and about 10.4%, due to mechanical forces. Now it is the time to talk about our project idea. To be honest, our idea is not a novel idea in the prosthetics in the world, but it is still a new technology to be used in the Middle East and in Egypt. We used a PLA filament, which we find that it is the best material used in prosthetics, to build our 3D model arm. The next step is to make each finger moves individually, and this is one of our challenges. So we have to select motors that have a high holding torque to be able to rise a heavy object without any induced current in the motors and without any deflection in the motors. But in our project, the dimensions and weight are critical parameters, so we have to care about them. So the motors should have a high holding torque and as small as possible. Due to this parameter we have to care about it, we decided to use NEMA 8 motors. As NEMA 8 has a suitable dimension, as we see it's about 2 cm in width, 2 cm in high and 2 cm long. Also, it is a very light motor with a high holding torque. Now let's talk about the signal, and how the motors start to rotate. As we know, the motors consist of coils. To make these coils rotate we have to pass a current to this coil, as we see. So we have two scenarios to pass current in the coil. The first scenario is to use a high-accuracy EMG sensor that can feel different patterns with each finger motion from the skin surface. We found that there is a highly accurate sensor called MyoelectricControlled. This band can read different patterns for each finger movement. This pattern can be sent to the microcontroller, which then sends a current to a certain motor to rotate. The second scenario, which is used by Bionic, is to save different hand grips on the microcontroller and use a button to choose the wanted grip. To be accurate, each grip have a sequence on the button. For example, if you need pen grip, then you have to press 3 times on the button before contracting the muscle. So in your opinion, what is the best scenario? To be honest, the first scenario is the best. But it's very difficult to find a sensor with this high accuracy to feel the difference in fingers' signal. This is due to the anatomy of the hand, as the muscles that control the fingers are in the wrist, not in the forearm. So if we said that there is no wrist, so it is very difficult to get the signal. What really done is that they see the effect of this muscles in the wrist on the other muscles in the forearm. This effect seen a certain pattern on the EMG signal of the forearm. So the sensor should be very accurate to get the small difference in the signals and draw different patterns. At the end, I would like to let you know that our project is still in progress. Till now we use the second scenario to send signals. Until finding the MyoelectricControlled band or similar sensor. Wait for us in the next video in August with the full project description and the final result. Thank you for watching. And I wish that this video was useful. Goodbye. This video was created by 4th year System and Biomedical Engineering students, Cairo University, Team 13.